Hi, this is a video on how to graph histograms by hand and by calculator. A few of you had questions about this, so I'm gonna make this video to answer those questions. Okay, I hope you're doing well. So let us get started. So what we have is basically a set of numbers, a data set, and we like to graph those using something similar to bar graphs, except for the horizontal axis is divided into classes. So that's the only difference. It's similar to bar graph. So let's start. So what is a histogram? Well, histogram is like a bar graph, but the bars are connected. Remember, bar graphs on the horizontal, we can have, categorical data, and then the bars are count or measures. But with histogram, the horizontal axis is actually numbers that is divided into classes, and the classes are actually attached here. They don't have spaces between them. And on the top here, you have some bar, just like bar graphs. You have a bunch of bars like this. So what you have to decide when you want to graph a histogram is with what number to start and with what number to end and how many bars you want. And so let's do that. Now, the trick here is, and I'm going to explain it a little bit more in a second, but the trick here is that if you have a bunch of numbers, you don't want any of these numbers to occur to be at the boundaries, because if you have a number at the boundary here, then does it belong to this bar or does it belong to this bar? It's kind of confusing. So in order not to have any of these fall on any of the boundaries, we use this trick that I'm going to show you in a second. So the trick is to make sure that the number of decimal places that we use on the boundaries is one more than the number of decimal places, the maximum number of decimal places used in the data. And I'm going to explain it in a second. Okay, so let me first, let's talk about how to get the points so we don't have any of the numbers falling on the boundaries. So we have to have a starting point. Our starting point is going to be the smallest number in the data, then minus either 0.5 or 0.05 or 0.005 and so forth. These numbers are convenient numbers to use for number of decimal places. For example, if the value with the most decimal places in the data is 6.1, that means the data has only one decimal place, right? Decimal place is the places after the decimal, right? So if all the numbers are integers, then the number of decimal places in the data is 0. If you have numbers with one decimal place, and that's the maximum number of decimal places we have, then the data has only one decimal place. So what we want to do, we want to make sure the boundaries have one more than that. So that's one decimal place, so we want the boundaries to have two decimal places. So what do? We pick this number. This number creates two decimal places. So what we get? We get the smallest value. So it says for example, if the value with the most decimal place is that, and this is the smallest value, not only has the most number of decimal places, but this is the smallest value in this case. So we're going to take 6.1 and subtract this number from it, which is going to create two decimal places. So we're going to start with this number. And then we're going to talk about with what number we're going to end, but for now, the starting point, okay? Now, what if the smallest, the most decimal place is this number? That means 2 decimal places. And the smallest value is 1.5. Then we're going to add 1 to this. So we're going to use 3 decimal places. And to create 3 decimal places, you have to use this number. Now, can you use 0.007? Yes. But this is a convenient number to choose. This is going to create 3 decimal places. So we take the smallest value, 1.5, and we're going to subtract that number from it. We're going to start with, in this case, we're going to start with 1.495. Okay? Let's do a few more examples. So what if the most number of decimal places is this number here, which is 3? So we're going to add 1 to it. So that's 4 decimal places we need. And the smallest value is 1. So we take 1 and subtract 4 decimal places, 1, 2, 3, 4. So we're going to subtract that from 1. So we're going to, in this case, we're going to start with this number. All right, so that's the starting point. That's how we decide. Here's another example. All the data happen to be integers. That means there is 0 decimal places. So we add 1. So we have to use 1 decimal place for the boundaries. What's the smallest value? 1.5. So 1.5 minus 0.5. 0.5 creates 1 decimal place. So 1.5 minus, 2, not, the smallest value is 2. So 2 minus, see it says the smallest value is 2. So 2 minus 0.5 is 1.5. So we start with 1.5. Also, when a starting value, starting point, and other boundaries are carried to 1 additional decimal place, no data value will fall on a boundary. That's why we use this trick. So let's look at an example. So here are a bunch of numbers. There are 100 of them. And they're already sorted from the smallest to largest, right? So the highest are... So here are heights in inches to the nearest half inch of 100 male professional soccer players. So if you look, you see that the maximum number of decimal places is actually 1, right? We don't have more than 1 decimal place, right? There is only 1 decimal place. There is no more that has more than 1. So that's 1 decimal place. So where do we start? So we're going to start with the smallest number minus what? Minus 1 more decimal place than we have in the data. The maximum number of decimal places in the data is 1. So we have to add 1 to it. So we need 2 decimal places. And the number that we use for 2 decimal places is this number. So we're going to subtract that from 60. Right? And we get 59.95. So our numbers for histogram should start from 59.95, right? All right. Now, how many bars do we want? Well, there is no rule that the standardized rule. So basically is take the square root on how many numbers you have. That's pretty a good number. You can round up or round down if you don't get an integer. So we have 100 numbers. So 10 is good. In this case, we use 8. Okay, again, you're told how many bars to use. You don't have to decide. But if you're doing a problem yourself, an application problem, you decide from maybe 5 to 15, bars. So if you use 8, right, then the smallest number is 60 minus 0.05, which is 59.95. And the biggest number is 74. We're going to take 74 plus 0.05. Remember, because we don't want any number to fall on the boundaries. So that number, which is 74.05, minus 59.95 is the distance that we want to divide into 8 parts, right? You want to divide that into 8 parts. So we want to know what is the length of each part. And we do that with the calculator, we end up with 1.76. So if I use the length of each class to be 1.76, then I'm going to start with 59.95 and end with 74.05. But any number greater than this also works for the length of the data. Because if you start with a number with 2 decimal places, no matter what we add to it, we still keep the 2 decimal places. So here, instead of, I meant this one, 59.95, has 2 decimal places. So if we start with this, whatever we add to it, we can keep 2 decimal places, right? So instead of adding 1.76 and get the next one, right, we can just add 2, round it to 2, just make the length be 2. So we start with 59.95 and keep adding 2 to get all of these boundaries all the way to the end. Now remember, if you make this number that you find here, the length of each interval, if you round it up, make it bigger number, then your largest number is going to be pushed back a little bit, but that's okay. So let's look at that. So here you go. So we start with 59.95 and we go by 2, add 2, add 2, add 2, add 2, and so forth, right? We end up with 75.95. Remember, that's bigger than the biggest number we had, is because remember, we round up. We made 1.762. So that's why. Okay? So now we have the boundaries, right? We don't have the bars yet. We have the boundaries. So now we go to the data and we're going to tally how many numbers are between 59.95 and 61.95. How many numbers are between those two numbers? How many numbers are between those two numbers? And the height of the bars could be percentage of numbers that are in this class, or it could be the total number of numbers that we have in each class. So the height of the bars could be percentages or numbers, right? Raw numbers. And we're going to look at both. Okay, now it's time to tally. And if you, let me go to, so we're going to know 59.95 and 61.95. How many numbers are in this? Well, look, this one, 1, 2, 3, 4, 5. This one is outside that range. So there are 5 of them that are where? That are over here. So 5 out of 100. So we can make this height all the way 5, or you could just make it 5%. 5 divided by 100 is 5%. So we put 0.05. And then we go again and tally, see how many numbers are between 61.95 and 63.95. So if you go to the data, you see how many numbers. It's going to be that one, those, right? Because is 63.95 the biggest one, and this passes that. All of these are in that range, so there are 3 of them. And this way we tally all the numbers and we have a histogram. Now the point, of course, is not for you to do these by hand. Nobody does it by hand in the fields. Now you could do a small number of numbers by hand like we do here yourself, but the reason we do it is to understand the structure of the histogram and what these numbers actually mean when you look at the histogram. The point is not to learn how to, just for the sake of graphing histogram. Nobody is going to pay you to graph histogram by hand. You know why? Because we have computers, and you see this is done by computer, and it does it in a fraction of a second. Why do we need a person to do this? We don't. And the reason you're learning this is not because you're going to go in an office and sit down and just graph histogram. No. The reason is, without doing this by hand, you're not going to understand the structure of these numbers, the histogram, and understand what these numbers actually mean. Here's the computer output. What do they mean, right? So now you understand what the histogram mean actually when you do one of these. Okay, so again, we have to decide on what to start with, and that is the smallest number. And then you have to decide how many decimal places you have to use for the boundaries. And the number of decimal places is one more than exists in the data, the maximum that is in the data. Okay, so let's do one with calculator now. Now, how do we do one with calculator? Well, to do one with calculator, we have to actually use a calculator. So why don't I just use a calculator here? Supposed to show up. Here you go. So you see, what we have here is a set of numbers, right? There are a bunch of numbers here. You know, there are a bunch of ones, bunch of twos, bunch of threes. You could just enter all of them in the calculator in one column. So we go to Stat, Edit. Let me clear this column. You go to the title of the column and press Clear, Enter. And 2, 2, I press Clear, Enter. Now, I could just put in the calculator, I could just put, 1, 1, 1, 1, 1, 1, 1, 1, but instead I can put a column of frequencies in the calculator. I can enter them. So I have 1, 2, 3, 4, 5, and 6. So I can put them in the calculator. So 1, let me put it here. So I have 1, 2, 3, 4, 5, and 6. And for the frequencies, I already counted them, so it's is over here, right here. So it's 11. I'm going to put 11, and then 10, 16, 6, 5, and 2. Okay. All right. So now we have to tell the calculator how to graph it. Now, can you just use a calculator? Yes. If you go to second stat plot and then turn the first plot on, usually it's off like that, so you turn it on, and you pick histogram right there. You see that's histogram. Press enter. And make sure X list is in L1. That means these numbers are in L1. And our frequency is not one of each, but is in L2. So we have to change that to L2. And if you go to zoom 9, and make sure Y equals to here doesn't have anything, so it's empty, because otherwise it graphs it at the same time. So again, we went to stat plot and we set it up. Now we go to zoom 9. And the calculator just automatically graphs a histogram for you based on the program that the engineers actually entered into the calculator. That's not necessarily the program we use to graph them by hand. So if you go to Window, you see what they use. They started with 1. And they go to a maximum of 6.7. And they chose the X scale to be 0.7. And notice that they use 1, 2, 3, 4, 5, 6, 7, 8 intervals, 8 bars. Let's say we don't want to do that. Let's say we want to change it to the way we want to graph it. So what's the smallest value we have? 1. And these are all integers, right? So the maximum number of decimal places is 0. So we add 1 to it, get 1. So we're going to use this number. So we're going to subtract 0.5, and we get 0.5, of course, right? So I'm going to go to Window and change the minimum to 0.5, okay? So here is the number we're going to start with, 0.5, and we did right here. I put it in the window. Now the maximum number, the biggest number is 6, so we're going to add 0.5 to 6, and we get 6.5. Here we go. We put it. So the biggest number is 6.5. Now, how many do we want? Well, let's see. We're not told how many. Let's do 6 of them. Okay. So I'm going to decide on 6 instead of 8 that the calculator did. So what I do, I take the biggest number, including what? Including that 0.5, because remember, we don't want boundaries to have any of these numbers. So 6.5 minus the smallest, which is 0.5, divided by how many do we want? 6. So 6.5 minus 0.5 is 6. 6 divided by 6 is 1. So that means if I go by 1, I'm going to be able to divide this into 1, 2, 3, 4, 5, 6, right? And I can do that. So I'm going to put the maximum to be 6.5, and I'm going to make the x scale is actually what's the increment that the calculator uses, and that is 1. Of course, we decided is right here. Oops, go back. Is right here. That's 1. So I put 1, and the y min. Now, y has to do with the bottom and the top of the bars. Usually the bottom we want it to be 0, but I put a negative number, maybe -1, just to make sure we see the bottom of the bars, right? So the bars are going to be here, so we want to see the bottom. So I just go below it, like maybe 0.5, right here. Now, y max is how many numbers in each class do you expect? Well, how many numbers do we have? We have 50, right? 50 numbers. You don't expect all 50 to be in one class, right? So pick a number, maybe half of that even is good enough. So I'm just going to put 15 for y max. In this case, bars, the height of the bar would be number of numbers, right? Okay, and don't worry about y scale and resolution. Just press graph. Don't press zoom 9. If you press zoom 9, it changes back to the factory setting, right? So we just go graph. You see? Now it looks like this has a little bit more than 15 that we put in there, right? One of them has 16. We have 16 threes. So I'm going to go back to window and change that 15 maybe to 18. And now here's the graph. Now if you press trace, you could go over each rectangle and it gives you the height, which is right here. Also, it gives you the edges, the boundaries. You see the boundaries here? Gives you the boundaries and also the number that we have in each rectangle. Okay? That's the idea. That's how you graph with the histogram with the calculator. All right? So these are calculator instructions in the notes. So I'm going to see an example in Newton Alto. See if I can. So here is an example problem in Newton Alto. You're given a data set with frequencies, and you're told to pick the right histogram. Now, this is really easy because what's the smallest number? 8. And these are all integers. So you do 8 minus 0.5, which is 7.5, right? So 7.5 should be the smallest one, and the largest one should be 16.5. So let's look at this. This obviously is not the answer because the smallest is 9.5. That's not the answer because the smallest is 5.5. This could be the answer. We're going to check it, but 7.5 is good. And the other one is not the answer, so it has to be this one. So if you see in eating out histograms by hand, use the method that we just did by hand. If you're asked to use a calculator or the problem looks like they use the calculator, then you use a calculator and just go to zoom 9. You don't have to change it. Okay? So again, if you use a calculator and you go to zoom 9, notice it does its own thing. You see? It's different from the one that we do. If you want it to look like the one that we do by hand, you change the window. Right? All right. So I'm going to go back and end this video here. Hopefully this is going to help you. All right? And take care of yourself and others. Okay? See you.